So in this lesson, we're going to be talking about rotations. By the end of class, you'll be able to perform a rotation. That's important, like we've said a couple of times, because transformations create congruent relationships. Congruent is the key to all geometry. And you know you get it when you can correctly rotate a figure. So there's going to be a couple different ways we can do it, but first let's start by talking about rotational symmetry. And that's just when a rotation maps onto itself. We talked about line symmetry in our last lesson. Line symmetry, you can fold it and it matches up with itself. Rotational symmetry, you turn it and it matches up with itself. So one of the things that we're going to be doing with that is figuring out the shape's rotational symmetry by dividing 360, which is like a full rotation, a full time around, by the number of sides. So just for a quick little demonstration, here's a square. It's got 4 sides, so that means it makes sense because we can turn it once, twice, 3, 4 times, and it's back on itself, back right where it started. So you can see all the way around. Same thing here with the octagon. 1, 2, every side matches up. 3, 4, 5, 6, 7, 8. And then you're back on the beginning. So since all the sides are even, they all match up. However many sides it has, that's how many times it will match up along the way. So divide 360 by that, by the number of sides, and that tells you what it's going to be. Hexagon, 6 sides, so 1, 2, 3, 4, 5, 6. So an equilateral triangle, it's got 3 sides. So all the angles along the way, you would do 360 divided by the 3 sides. You get 360 divided by 3 is 120. All of those stops along the way. So if you go another 120 degrees, that's going to be 240. And then we can end on, if you add it again, you get 360 degrees, which everything's got 360 degree rotation. You spin something around one time, it's back where it started. So sometimes the 360 degrees won't even be written because it's not special. A square's got 4 sides, so you do 360 divided by 4. That's 90. Now if you turn to the second time, that'd be another 90, so that's now 180. If you turn it another time, that's another 90, so that's 270. And if you turn it another time, that's another 90, which is 360. Like I said, sometimes the 360 is not written out. For a pentagon, that's 5 sides. Pentagon means 5. So you do 360 divided by 5, which is 72. Another 72 degrees on top of that would be 144. And then another 72 would be 216. Plus another 72, 288. Plus another 72 is 360, back where you started. A hexagon, that's 6 sides. So do 360 divided by 6. 60. And again, that's another 60, that's 120. turn it again, another 60 is 180, another 60 is 240, plus 60 more, and plus the last 60 puts you back at 360. This next one, the math is pretty hard. Heptagon means 7 sides. And I've only met one person in my life that likes dividing by 7 or could divide by 7 in their head. It's not me. So, divide by 7, you get 51.43 about, I'm rounding. Add that on again. You get 102.86 if you round it. Add it on again, you get 154.29. And again, 205.71. And again, 257.14. Another one, 308.57. And one more time, you get 360. So the next one, octagon. That's 8 sides. So you do 360 divided by 8. It's 45. Another 45 is 90. Another 45. And another one. And another one. $270, 315, and 360. Nonagon, that means 9 sides. So 360 divided by 9. $40. Then you get 80, 120, 160, 200, 240, 300, and 360. And then our last one here, decagon, that's 10 sides. So you do 360 divided by 10. It's 36. Another 36 is 72. Another 36 is 108. Another 36 is 144. And then 180. $216, $252, $288, almost done, $324, and then the last one will be $360. And you're back at the start. So divide by the number of sides, and then keep adding it to itself. It tells you all the stops along the way. So point symmetry is a little bit more exciting. That was kind of boring. A little bit more exciting here with point symmetry. That just means that you can rotate 180 degrees and it matches up with itself. You can rotate 180 degrees and it looks the same as it started. It matches up with itself. Same thing with this graph here. If you rotate it, the graph looks about the same as it did before I rotated it to begin with. This one, you can see it matches up. And this is my favorite. I forget what this type of art's called, but rotate it, and it's the same thing. Rotate it, same thing. So 180 degree rotation, rotational symmetry is called point symmetry. All right, so now moving on to some real math-like examples. Determine the point for the following figures that have point symmetry. So we're trying to figure out what point we can rotate around that's going to match this up. So for some people, you can kind of just spot it out. Sometimes it's hard, but for a lot of people, you can just kind of spot it out. And if you hold this point right here, still with your pencil, and spin some tracing paper or the plastic clear sheet around, it matches up from this point right here, -1, 0. There's another way to figure it out though too, and it's also foolproof. If you can identify what points match up. So if this was the pre-image, so if this was like A, that would match up with this side over here, A prime. For this, if I color this point green, that is going to match up when you rotate it around with this point on the triangle over there, that vertex. And then the third point with the third point. So if you can identify those points, you can also connect them. And when you connect all three of those, all three of them intersect right there at the point that gives you the rotational symmetry. They all pass through. So that's yet another way to do it, kind of foolproof. It works every time. If you connect the points that need to match up, connect the image to the pre-image, it tells you that that point right there is where you can spin it. -1, 0. Pretty cool. All right. So rotations, a little bit more. You just got an idea of it because that's what we were doing. We were spinning shapes around. You turn or spin all the points about a fixed point. Remember, the pre-image and the image will be congruent. The pre-image and the image are going to be the same. So all the angles are the same, all the side lengths are the same. Just turns every point the same angle. So when you do a rotation, shape, side lengths, angles, angle measures, orientation and parallelism all stays the same. None of that changes. But position is going to change because you rotated it, you moved it. So the pre-image and image are going to be congruent. So they're going to have all the same size and shape, but it's going to be moved. So how do you know when to do a rotation? The most obvious way, it's going to say rotate it. It'll tell you how many degrees and what direction, clockwise or counterclockwise. So clockwise, if you have a ticking clock around you anywhere, just watch the second hand for a couple of seconds and you'll see which way is clockwise. Goes that way. That's clockwise. And obviously counterclockwise would be the other way. So just like reflections and translations, there's also rules that go with it. So here's the one for 90 degrees clockwise. You switch the location of them, X and Y switch places, and then you change the sign of the starting X value. And then probably the least used, but a rotation, and this would actually say negative 90 degrees. Negative 90 would be clockwise, and if they did a positive, negative clockwise, positive is counterclockwise. If they use that notation. The only way I can really maybe explain it to you right now is that you remember your quadrants start with 1 right there, and then 2, 3, and 4. So it would make sense that if you're going positive, you're going to go from 1 to 2 to 3 to 4. So going that way will be a positive angle, which is counterclockwise. So here we're asked to rotate 90, 180, 270, and 360 degrees counterclockwise. So you can trace it and then hold the origin still because it says around the origin. Trace it and hold the origin still, and then you just have to kind of peel up your tracing paper and then draw where the points were. So hold the origin still, rotate it around, it ends up right there. And you can kind of lift up your paper and draw your triangle. A prime, B prime, C prime. So that was 90 degrees counterclockwise. You can turn it again, another 90 degrees. Now you're at 180. And then lift up your tracing paper. So this would be A double prime, B double prime, C double prime. This is the second stop, the second time we moved it. Yep. So then draw your triangle. This would be the 180 degree rotation. You rotate another 90. That's now our 270 degree rotation. Prime, prime, prime on this one, 3 primes. And this would be B triple prime and C triple prime. Does it say 360 also? 360 is going to put you back where you started. Rotate it one more quarter turn, and you're right back where you started. So Yeah, and that would be like four primes. We're back where we started. So rotating around the origin, especially with some tracing paper, pretty easy. Could be a little bit more difficult when they tell you to rotate around the point -1, 0. So same thing. On your tracing paper, we're going to trace this out. And we're going to hold the point -1, 0. That's where your pencil is going to go when you spin your paper. So you're going to hold that point still when you trace it out. So it's a little more complicated on this computer. Just 90 counterclockwise. So I can turn it, and then I have to kind of redo my point on the computer here. So 90 counterclockwise, that's that direction. Turn it 90. And I just have to move my point back where it's supposed to go. It's a little bit easier with paper for you to trace it out and hold that point still with your pencil. So then this would be M prime, this would be A prime, T prime, and H prime. But we only had to rotate it 90 degrees. We didn't have to do all of them. So that's it. Rotate XYZ 180 degrees around the origin. So you're holding the origin still this time, 0, 0. And rotate it 180. So this is X prime, Y prime, and Z prime. Last one. No, that's not a typo. 900 degrees. It's not as bad as it sounds. Yeah, it's going to be more than one circle, more than one 360. So the easiest way to figure it out is just subtract 360 from it until you can't anymore. So if you subtract 360 from that, you get 640. Subtract 360 again. I don't think that was right. 540. Subtract 360 from 540, you get 180. So it's 2 full circles and then 180 degrees. So we're only going to rotate it 180 because that's kind of the simplified version of it, counterclockwise, and it says around the right angle vertex. So that's right here around C. So we're taking our shape, we're rotating at 180 counterclockwise, 180 counterclockwise, and we're supposed to be holding that point C. It's supposed to be the still point, right there. So this becomes A prime, and this will be B prime. So we gave the rule earlier for the 90-degree clockwise. I think was the first one we gave you. So we're going to go through them all, starting with 90 degrees counterclockwise, which is the same thing as a 270 degrees clockwise. You think about that, 90 degrees is like a quarter turn. If you went the other way, 3/4 turn, it's the same thing. It's like 3 left is the same as the right. And that rule is XY goes to negative Y X. (180 degrees, it doesn't matter which direction you go, clockwise or counterclockwise, it's the same 180 degrees. And that's XY goes to negative X, negative Y. Just change the signs. And then 270 counterclockwise would be the same as 90 clockwise. And that rule, XY goes to Y negative X. So you can check this out with any of them that rotate around the origin. This is all about the origin. If it's not about the origin, there's not really a rule for it. Or at least it's much more complicated. So just as a demonstration, we'll go back to this example real quick. 180 degrees about the origin, that means we can use the rule. So let's just check some of these points, like Y. Y started out at -4, 0. The rule for 180 says that it's going to take XY and go to negative X, negative Y. So it's going to take the -4, change it to a +4, and 0, change it to a -0, still 0. So that makes sense. You can do the same thing with X. That's over here at -2, 2. Changes those signs. So -2 is going to turn to a +2. And then the +2 is going to turn to a -2. 2, -2. So you can follow the rule also and make it work out. I think the paper, if you've got it, is easier just to hold it still.